Hi, I am Himanshu Dembe, a final year BTech student from IIT Guwahati. Today, I'll walk you through my project, NLP based project titled Sentiment Analysis of Consumer Product Reviews, which is hosted on GitHub. So, what problem nowadays we are facing? So, nowadays in e-commerce, reviews are powerful. However, manually analyzing thousands is infeasible. My project focuses on automating this using NLP and ML to classify reviews as either positive or negative, helping brands making data-driven decisions. So to do this, I firstly prepared the dataset. So the dataset is been taken as 35,000 Amazon reviews from toys and games category. Reviews rated 4 or 5 are labeled positive, 1 or 2 as negative, and 3 as neutral. 3-star reviews are excluded to avoid ambiguity. The core feature used is review text and the label is derived from the overall rating. Okay, so that now we have got the data, so we have to pre-process this data also, as it has been a crucial step in NLP. Therefore, I pre-process the text using standard NLP technique, that is lower casing, removing stop words, and lemmatization. Then I converted the clean text to numerical form using TF-IDF, capturing both unigram and bigrams with max vocab size of 10,000. So now we will talk about the model architectures. So I have implemented both classical models like naive Bayes and logistic regression and deep learning models like LSTM. So the naive Bayes is a probabilistic classifier well suited for high dimensional text data, whereas a logistic regression is a linear model that works well for binary classification. I have also tried another model which is random forest, an ensemble of decision trees, which adds non-linearity and handle feature interactions as well. So all models were evaluated using weighted F1 score, which balance precision and recall, especially for imbalanced dataset. So in long LSTM, one hidden layer with 128 units are being used, and embedding layers are used to convert words to dense vector before feeding it back to the LSTM. So the weighted F1 score is also used to balance precision and recall across both the classes. Now, as we walk through, we have also used the deployment pipeline. So the deployment pipeline is being made using AWS Elastic Beanstalk containerized via Docker, a Flask API handle inference, and I built a CD pipeline with GitHub for an AWS Beanstalk for smooth updates, which can be seen in the code base. So now, as we have used various model for to calculate the result and show how each model is being performed, we will calculate accuracy and the F1 score. As you can see in the bar graph, where accuracy is labeled in blue and F1 score is labeled in red. The LSTM model outperformed all other with a 91.4% accuracy and 0.14 F1 score. Among classical model, logistic regression led with 0.891 F1 score. This shows that while simpler model do well, deep learning captures sequential dependencies more better, and in that LSTM performs the best. So now we will talk about what challenges we faced and the error analysis to be done for this project. So some failure cases where the model may not perform well are the comments which are mainly sarcasm and irony, which have mixed sentiments or which are noisy reviews. Mixed sentiments like good toy but broke quickly, through which we cannot calculate how the comment is being a positive or a negative one, or misclassified reviews such as expected better quality for the price. Some challenges include sarcasm and mixed sentiments in single sentence. So, what are the takeaways that we can handle these errors? What are the takeaways we can handle this error? Therefore, we need more context-aware models like transformers, like BERT, sentence-aware embeddings, and possibly incorporating user metadata or review history also to improve the context. Now we will talk about how this model, that is my project, incorporates multimodal learning. So this project incorporates early stage multimodal learning by combining text with ratings, as we can see in the image. Future extensions could include product image, audio reviews, or even user metadata, allowing more holistic sentiment prediction using fused representations. So now, what are the conclusion and the key takeaways? So, we can in the takeaway we can suggest that to build a robust sentiment of analysis pipeline. And one of the major key takeaway is the in the sequential data where like text, the where memory matters, LSTM perform better from up as compared to all classical ML models. This project is based on a continuous deployment CD pipeline using ADS. And also in future, we can use BERT models where more modalities and real-time analysis could be performed.